Imagine stepping into the hushed, cavernous halls of a medieval European scriptorium around the year 1000 AD. The air is thick with the smell of beeswax and damp parchment. Dozens of monks sit hunched over sloped desks, working in silent concentration by the flickering light of candles. To create just a single copy of a Bible, a scribe might labor for an entire year, meticulously copying each letter by hand. The material itself was staggering in cost. A large book required the skins of hundreds of sheep or calves, painstakingly scraped, stretched, and dried into vellum. Pigments for illuminated letters were ground from precious stones and rare minerals. Because of this agonizingly slow and ruinously expensive process, books were extreme luxury items. A single volume could be worth as much as a small farm. Knowledge was locked away in the fortified libraries of monasteries and royal courts. The vast majority of humanity lived and died without ever holding a book, their world bounded by what they could hear and remember. The flow of ideas across continents was a mere trickle, constrained by the physical limits of human endurance. But long before the familiar story of the European printing press, the desire to mechanically reproduce the written word had already sparked brilliant innovation in East Asia. As early as the 2nd century AD, Chinese inventors had developed paper, a crucial and inexpensive prerequisite for printing. By the 8th century AD, during the Tang dynasty, they had mastered woodblock printing. In this method, a skilled artisan would take a smooth block of pear or jujube wood and meticulously carve an entire page of text and illustrations in reverse. The raised surfaces of the block were then inked, and a sheet of paper was pressed against it. This was a monumental leap forward in the mass production of texts. The famous Buddhist text, known as the Diamond Sutra, printed in 868 AD, stands as a stunning testament to the sophistication of this early technology. However, woodblock printing possessed a fatal flaw. It was entirely rigid. If an artisan made a single mistake while carving a complex character, the entire wooden block was ruined and had to be discarded. Furthermore, a carved block was utterly useless for printing anything other than that specific page. To print a massive work, tens of thousands of individual wooden blocks had to be carved, requiring enormous storehouses simply to keep the heavy blocks safe from rot and fire. The solution to this rigidity was the concept of modularity. Instead of carving a whole page into a single block of wood, what if one carved individual characters that could be arranged to form a page, printed, and then separated and rearranged for a completely different text? This was the genesis of movable type. The first person recorded in history to achieve this conceptual leap was a Chinese artisan named Bi Sheng. Working around the year 1040 AD, Bi Sheng carved individual Chinese characters into pieces of moist clay, which he then baked in an oven to harden into ceramic type. To prepare a page for printing, he arranged these fragile ceramic characters inside an iron frame resting on a metal board. The board was covered with a sticky mixture of pine, resin, wax, and paper ashes. By heating the board over a fire, the resin mixture melted, locking the characters firmly in place as it cooled. After the printing run was finished, the board was reheated, the resin melted again, and the individual characters could be plucked out, cleaned, and stored for future use. While highly ingenious, Bi Sheng's ceramic type was brittle and prone to shattering under the heavy pressure required for clear printing. 2.5 centuries later, around 1298 AD, a Chinese magistrate and inventor named Wang Zhen vastly improved upon Bi Sheng's concept by utilizing wood. Wang Zhen systematically carved tens of thousands of wooden characters. Recognizing the immense difficulty of finding specific characters among thousands, he engineered a spectacular system of massive revolving wooden tables, some measuring 7 feet across. The typesetter would sit comfortably between two of these rotating wheels. Spinning them too quickly retrieved the exact characters needed. This mechanical innovation made the typesetting process dramatically faster. However, wooden type possessed its own inherent limitations. Wood is a porous material. It absorbs the liquid ink and inevitably swells. Furthermore, the constant repetitive pressure of the printing process wore down the fine, sharp edges of the wooden characters, causing the printed text to become increasingly blurry and illegible over time. The ultimate medium for movable types, something durable, perfectly uniform, and capable of producing crisp impressions, endlessly remained elusive. The true breakthrough to durable metal movable type did not occur in Europe, but on the Korean peninsula during the Goryeo dynasty. In the early 13th century AD, the Korean kingdom was under immense existential pressure. Ferocious Mongol invasions were ravaging the land, and in 1232 AD, Mongol forces deliberately burned the repository containing the 81,000 wooden blocks of the Tripitaka Koreana, a massive collection of Buddhist scriptures, in a desperate bid to preserve their sacred texts and their cultural identity, and believing that reproducing the texts would secure divine protection against the invaders. The Korean royal court turned to their highly skilled bronze casting artisans. They realized that the sophisticated metallurgical techniques used to cast bronze coins, bells, and statues could be adapted for the mass production of printing type. Around the year 1234 AD, a civil minister named Cho Yan-Ui directed the colossal project of printing a massive 50-volume prescriptive text on social etiquette called the Sangjeong Gogeum Yemun. To accomplish this unprecedented task, he and his team successfully cast movable type out of bronze. This stands as a monumental achievement in human history, the very first books ever printed using metal movable type. The Korean artisans utilized a painstaking technique known as sand casting. They would first carve a master character in wood, then press that wooden character firmly into a box of highly compacted fine sand to create a perfect negative impression. Molten bronze was then carefully poured into the sand mold. Once cooled, the result was a highly durable piece of metal type that could withstand thousands upon thousands of impressions without losing its razor-sharp edges. Despite this incredible technological leap, metal movable type did not immediately trigger an explosive information revolution in East Asia as it later would in Europe. The primary obstacle was not technological, but linguistic. The Chinese writing system, which was widely used across East Asia, including by Korean scholars at the time, consists of many thousands of unique logographic characters. To operate a functional printing press, an operation required casting, organizing, and securely storing hundreds of thousands of individual metal pieces. The sheer complexity, massive physical space, and exorbitant cost of maintaining such a massive inventory meant that metal movable type in Korea remained largely a state-sponsored enterprise. It was utilized primarily for printing vital government documents and crucial Buddhist texts. Rather than evolving into a commercially viable technology for mass public literacy, nevertheless, their engineering achievement remains a pinnacle of early innovation. The oldest surviving book printed with metal movable type is the Korean Jikji, a profound collection of Buddhist teachings printed in 1377 AD, nearly 8 decades before Gutenberg's famous Bible. As the 15th century AD dawned, the focus of the printing revolution shifted halfway across the world to the bustling, competitive mercantile cities of Europe. Europe was undergoing a profound societal transformation. The lingering devastation of the Black Death had passed, and the economy was rapidly recovering. The rise of great universities in cities like Bologna, Paris, and Oxford, along with the growth of a literate, urban middle class, had created an insatiable demand for books. The traditional guilds of stationers and scribes were completely overwhelmed and simply could not hand-copy texts fast enough to meet the demand of students and scholars. It was within this fertile, desperate environment that Johannes Gutenberg, a skilled goldsmith and ambitious entrepreneur from the city of Mainz in present-day Germany, began experimenting with mechanized printing in the 1430s. Whether Gutenberg was aware of the earlier East Asian printing inventions remains a subject of intense historical debate. The vast network of the Silk Road had long facilitated the exchange of goods and ideas across continents, and it is entirely possible that rumors, travelers' accounts, or even physical examples of printed materials from the East had reached European markets. However, most historians agree that Gutenberg's system was a wholly independent invention, primarily because the underlying mechanics of his process were fundamentally different from the sandcasting methods utilized in Korea. Gutenberg approached the problem not just as a printer, but through the precise lens of a master metallurgist and a jeweler. He called his highly secretive project the work of the books. Gutenberg recognized that to make movable type commercially viable and profitable in Europe, he needed a way to produce thousands of perfectly identical, interchangeable characters quickly and cheaply. Here, Europe possessed a massive linguistic advantage, the phonetic alphabet. Instead of tens of thousands of unique logographs, European languages required only a few dozen individual letters, numbers, and punctuation marks. However, to print an entire book, a printer still needed thousands of identical copies of those few dozen characters. The letter E alone might appear hundreds of times on a single page, Gutenberg's most brilliant and transformative innovation. Arguably even more significant than the mechanical press itself was the invention of the hand mold. This was a two-part, adjustable metal mold that allowed for the incredibly rapid and precise casting of type. The rigorous process started with a puncha small stick of hard steel, with a single letter carved in exquisite relief on the end by a master engraver. A single slip of the file meant starting over. This steel punch was then hammered with immense force into a softer piece of copper, creating a perfect indented impression called a matrix. This copper matrix was then inserted into the bottom of the adjustable hand mold. The next critical step was perfecting the metal itself. The bronze used by the Koreans required extremely high temperatures to melt and shrank unpredictably as it cooled. Pure lead, while easy to melt, was far too soft and would quickly deform under the immense pressure of a heavy press. Through years of relentless secret experimentation, Gutenberg formulated the perfect typographical alloy, a precise mixture of lead, tin, and antimony. Lead provided the heavy bulk, tin added essential toughness, and antimony possessed a rare and almost magical property, actually expanded slightly as it cooled from a liquid to a solid. When this molten alloy was poured into the hand mold, the expanding antimony ensured that the metal forced itself into every microscopic crevice of the copper matrix, resulting in a razor-sharp, flawless letter form. A skilled artisan using Gutenberg's hand mold could cast thousands of perfectly uniform metal letters in a single grueling day. But the precise metal type was only one part of a complex, interdependent system. Traditional water-based inks, which had been used successfully for woodblock printing in East Asia, were entirely unsuited for metal. The watery ink would simply bead up and run off the smooth metal surfaces of Gutenberg's type. To solve this critical issue, Gutenberg drew upon the techniques of Flemish painters who had recently pioneered oil painting. He developed a completely new type of printing, Inca incredibly thick, viscous, sticky mixture made from lampblack soot, heavy varnish, and boiled linseed oil. This robust oil-based ink adhered perfectly to the metal type and transferred crisply and permanently onto the paper without bleeding or smudging. Finally, Gutenberg needed a powerful mechanical device to apply even immense pressure to transfer the thick ink from the metal type to the paper. For this, he brilliantly adapted the design of the heavy wooden screw presses that had been used for centuries. Throughout the Mediterranean region for pressing olives for oil and grapes for wine, the modern printing press was born. The typesetter would meticulously arrange the individual metal letters into lines and then bind them into full pages. This form was placed onto the flat bed of the press and inked by hand using heavy leather balls stuffed with wool. A sheet of slightly dampened paper was carefully placed over the inked type, and the printer would pull a massive wooden lever. The heavy wooden screw would turn, bringing down a flat wooden block called a platen, which pressed the paper firmly and evenly against the inked metal with tremendous force. After years of secret development, endless trial and error, and crippling financial debt, Gutenberg was finally ready to demonstrate the world-changing power of his invention. Around 1455 AD, he completed his magnificent masterpiece, the 42-line Bible. It was a massive undertaking, running to over 1,200 pages in 2 volumes. Gutenberg printed roughly 180 copies, some on high-quality paper and some on incredibly expensive animal vellum. The quality of the Gutenberg Bible was absolutely astounding. The dense black text was perfectly aligned. The ink was a deep, lustrous black, and the pages possessed a uniform, geometric beauty that rivaled and in many ways surpassed the finest hand-illuminated manuscripts of the era. It proved beyond any doubt that a machine could produce books of exquisite quality, and do so in a fraction of the time it took a scribe. Tragically, just as the Bibles were being completed, his primary financier sued him for his massive debts, ultimately seizing control of the printing equipment and the finished Bibles, leaving Gutenberg bankrupt. Despite Gutenberg's personal financial ruin, his printing press ignited an immediate and unstoppable explosion of information across Europe. The synergy of the simple phonetic alphabet and the highly efficient hand mold made printing immensely profitable. By the time Gutenberg died in 1468 AD, printing presses had already been established in several major European cities. By 1500 AD, at the close of a period known as the incunabula, there were active printing presses in over 200 cities across the continent. Printers like Aldus Manutius in Venice began producing smaller, highly portable pocketbooks. It is estimated that more than 20 million individual books were printed in those first 50 years alone. Staggering figure that likely represented more books than had been produced in all of Europe during the previous millennium. The profound societal impact of this technological tsunami is impossible to overstate. Information, which had once been a tightly guarded and incredibly expensive commodity, suddenly became cheap, abundant, and impossible to control. The sudden availability of identical texts revolutionized education and scholarship. Scholars across the continent could now reference the exact same page of the exact same book, allowing for unprecedented collaborative research and the rapid accumulation of knowledge. It laid the essential foundation for the scientific revolution, as scientists could widely publish their findings and methodologies, allowing others to verify their experiments and continuously build upon their discoveries. The printing press also fundamentally shattered the monopoly on intellectual and spiritual authority held by the church and the state. When an obscure monk named Martin Luther nailed his 95 Theses to the door of the Wittenberg Castle Church in 1517 AD, his radical ideas did not remain confined to a local theological dispute. Sympathetic printers quickly translated his complex Latin arguments into everyday German, printed them by the tens of thousands in small, inexpensive pamphlets, and distributed them rapidly across Europe. The Protestant Reformation, driven largely by the raw, uncontainable power of the printed word, irrevocably altered the political and religious landscape of the world. As this revolutionary technology spread globally over the ensuing centuries, it encountered unique challenges in different cultural contexts. For example, as printing spread across the Mediterranean and into the Ottoman Empire, the beautiful, interconnected cursive nature of Arabic script proved vastly more difficult to adapt to. Discrete movable type than the simple block letters of the Latin alphabet. Even in regions like Palestine, modern-day Israel, hand copying remained a dominant form of textual transmission for centuries longer, highlighting how the physical and artistic characteristics of a language could dictate its initial compatibility with this new mechanical technology. Ultimately, the invention of metal movable type, born from the brilliant early innovations of Chinese and Korean artisans and perfected by the mechanical genius of a German goldsmith, remains one of the most consequential turning points in the entire history of our species. It broke the ancient chains of ignorance, democratized access to knowledge, and permanently altered the trajectory of human civilization. The deceptively simple act of pressing an inked piece of carefully cast metal against a sheet of paper was the spark that illuminated the modern world. A technological lineage that leads directly from the wooden wheels of Wang Zhen to the digital pixels illuminating our screens today.